All right. Greetings, everyone. My name is Jovari St. Victor. I am the founder of Tenorisk, a IT consultancy that is helping businesses to scale technology while doing it securely. And I am accompanied by my fellow colleague, which needs no introduction, but I'll let him introduce himself.
Thanks, Javari. I'm Stan Trepidon. I'm co-founder and CEO of Optimal Cipher. We've invented some novel technologies for doing homomorphic encryption, which allows organizations to collaborate and do analytics over encrypted data without decryption. Plenty of use cases for that. And today we're going to talk about actually something that broadly interests the community at large, which is the secure software development lifecycle.
Yep.
Javari, do you want to?
Yeah, definitely. A little bit more. Thanks, Stan. So as Stan alluded to, so we'll be talking about securing the SDLC process. So a lot of our technology professionals know about the SDLC process, which is called the software development lifecycle or system development lifecycle. So what we'll be doing, we'll be breaking down the objectives, but really putting a information security spin on this. So we want to do this and we want to reach out to all our governance, risk, and compliance professionals, our IT directors, our CIOs and CTOs. So we want to be able to provide you all with the tools, the questions that you can ask your team, the project team, when implementing a new system, when implementing a new application. And so we'll be doing what is called shifting left. And I believe Stan will get into that a little bit more, in which we'll look to add security considerations earlier in the process. So after this, you'll be able to know how to articulate security risks by phase of the SDLC process. I'll pass it on to Stan to break it down, the SDLC process.
Great, thanks, Javari. So as perhaps many of you may know, there are several phases to a standardized SDLC process, which starts from the requirements phase and ultimately winds up in the release phase. Basically, we can look at sort of 5 standard phases. The requirements phase indeed is the place where you gather requirements for a particular software project. Then the design phase is when you turn those requirements into, for example, a design document, and you begin to specify the architecture of the software itself. That's followed by the development phase, or the coding and building phase, where you convert the architecture and those initial requirements into an actual software project with modules, methods, and so forth. This is when developers sort of spend a good deal of time creating those artifacts. Then we have the testing phase, which is an amalgamation of various activities from actual unit testing and regression testing to quality assurance, to user acceptance testing, and so forth. And the last phase, perhaps one of the key ones for an organization, is the release phase, where you release the software into production and it goes live. And I should point out that while we're talking about what may sound like the waterfall kind of software development process, this can equally apply to the agile development process and so on, as some of these phases feed back upon themselves, and you may go a little bit forward and a little bit backwards as you're doing all these phases, some of them in parallel, depending on corporate policy in your development processes. And indeed, as Javari pointed out, what we're going to talk about is the shift left process, which basically tries to introduce security as early as possible, but just in general, introduce security into all of these phases, with the goal being that you don't wait till the end, but rather think about security throughout. The basic concept is the later you think about security or worry about security, the more expensive it becomes for your organization. It's much more expensive, for example, to fix bugs and vulnerabilities in the testing or the release phase than it is in the requirements and the design phase. So our goal in this presentation is to hope that everyone thinks about security early and really thinks about security throughout the process. Jivari,
Awesome.
you want to maybe talk about some of the risks that you may see there?
Yeah, definitely, Stan. So, and thanks for breaking that down. And as you noted earlier, it's not only applicable to the waterfall, but also agile, right? So we have the whole continuous integration, continuous deployment model that's going on. And I believe, Stan, you'll talk about that a little bit more. So that includes that as well. So you want to be able to consider all these specific questions and tools and techniques that we're asking, because there are risks, overall risks. There are so many risks. I'm going to outline just about 3 of them. One of them, which is pretty much self-explanatory, if you're not following an SDLC process, then you're not going to meet the business objectives, right? Or you're going to create a product that does not meet the customer's needs. That's always a risk. Another risk is delays in the project. So delays in certain phases, and delays leads to increased costs. And so increased cost, timelines, and things being rushed in order to meet a timeline. And so that's another risk. And the risk, which is where we're going to be concentrating on, is vulnerabilities. So if you're not following some of the basic SDLC process and including security considerations, then you're going to be introducing vulnerabilities into your entire IT environment. And that's something that you don't want to do. All right, so overall risks, let's get into the first phase, which is the requirements phase. So when we think about the requirements phase, what is that? That's pretty much understanding what this project is, what the system is going to do. It's really stating the objectives. What is the system? Why is this system, why does it need to be built? Who is it going to impact, right? So that's part of that requirements phase. And within the requirements phase, you'll usually break out the requirements into 2 parts, your functional and non-functional. Your functional is more of the system must calculate invoices automatically. Your non-functional could be, for example, the system must handle thousands of users simultaneously. And security, which is where we're focusing, is a non-functional requirement. And so it's pretty important that you understand and that everyone is involved in that specific phase. Now, common issues that we tend to see when we're working with clients implementing new applications, software. One is an oversight of regulatory requirements. So not understanding the types of data that will be processed. So if the data is submitted to or subject to PII, then there's certain regulations. If the data is going to be crossing over to the EU and back, then you have GDPR requirements, right? So that's one key thing that tends to happen. Stan, what's another key item from requirements perspective that tends to happen?
So indeed, from a security perspective, as we pointed out, because security is a non-functional requirement, it's often left out of the requirements conversation. And as a result, there are implications to the final product, right, once it's finally released. If security is left out and questions are not deeply considered in terms of things like the integrity of information, availability of information, and so forth, you could have things like basically a misuse of the product by various threat actors, once the software is live, right? So we're talking about actual vulnerabilities because they were not considered at the outset. Data can in fact be stolen. There could be a lack of auditing of either critical tasks by the application or even of security processes that you may need to adhere to, including, by the way, the very same regulatory issue that you just pointed out could in fact lead to non-compliance of the application because, again, no one thought about sort of regulatory impact on the application itself, and therefore the application may wind up being non-compliant. So there's a whole slew of issues because security is a non-functional requirement that could be left out of the requirements phase, which we want to kind of just highlight here a little bit that it's important. Right? It's important to think about those things so they're not left out from the process.
Right. And if I could jump in, Dan, you mentioned a really great point. And at the end of all this, the team has to be able to understand what level of risk that they can tolerate, what level of risk that they can accept in reference to the system. And we usually recommend that the project team understands what's the organizational risk tolerance or threshold, because each application, each system, once it's inputted into the environment, it raises the risk level or the risk profile of the company. So I think that's something that risk level acceptance phase, right, as part of requirements should be included.
Indeed, and so then taking this to the next step. Well, how do we think about security in the requirements phase? Is in fact is to make a conscious choice to take this step, right? So it means you do have to think about both security and privacy, as well as sort of industry best practices when it comes to embedding security into the requirements phase. It means you have to understand application functionality, as well as expected user experience. Perhaps think about some of the trade-offs, right? Introducing more security into the application might lead to potentially a slightly worse user experience. Those are decisions that have to be thought of at the outset. And as Javari pointed out, when it comes to risk appetite and risk acceptance of the organization, you have to sort of make those judgment calls of what to include, what to exclude. Not every organization is going to make the same decisions in all of these phases, frankly, even given the same application, because every organization thinks about risk a little bit differently. Our point here is not to prescribe what you should do. It's just to remind you that you need to think about this and adjust the security controls in the requirements phase to what your risk appetite may be.
Right.
And that way, hopefully, the final product will meet your requirements. And Javari, do you want to talk a little bit more about risk and then what questions may come up in the requirements phase?
Definitely, Stan. Thank you for that. I think so. You understand the requirements, common issues. Now it's what are some of the questions that you can ask the project team or the IT team, the implementation team? Like, what are some of those questions during this phase? There are a whole lot, but we'll outline maybe 2 or 3 which we think are key. The first one is, does the system contain or come in contact with any data? What kind of data? Is it subject to PII, GDPR, CCPA? Like, that's something that you want to understand. Does the application perform any risky software activities? For example, does the application allow users to upload files? So that's considered a risky activity because PDFs, Word documents, Excel spreadsheets, threat actors or hackers can exploit these document types by inputting scripts. So scripts are little programs and they tend to be malicious in their intent. And a person could upload a PDF or Word document along with these scripts and really do a lot of damage. And so you want to understand what kind of risky activities the application does. And does the application require for it to be up all the time? Does it require it to be up 99.9% of the time? How critical is the system? So those are a few questions we would tell our clients to ask during the requirements phase. Let's go into the design phase. What do you think, Stan?
Definitely. Thanks, Gerard. Yeah, so after the requirements phase is the design phase, like we mentioned, where we convert requirements into, for example, a design document. And indeed, here both functional and non-functional requirements become blueprints, right? You produce an architecture, it could be a network diagram, and so forth. Perhaps you begin to create some pseudocode, but here is where kind of the vision from the requirements becomes more concrete and becomes an architecture. Again, as in the requirements phase, there are some common issues that may arise in the design phase too. Jawari, do you want to highlight some of them?
Yeah, definitely. So as Stan noted, the design phase is where you're taking all these ideas, making them concrete. The design phase is super critical. And you want to make sure that as a governance, risk, and compliance professional, as an IT director, that the team is paying close attention here, because there are some common issues, a lot of issues. We'll only address just a few. One of them is not getting buy-in from the right stakeholders or all the stakeholders. So you may have this great application, this great software you created, but the right stakeholders weren't part of the decision process. And so there could be a key feature that's missing. So that's one common issue we tend to see. There tends to be an incomplete list of functional specifications, which is the translation of the requirements into something more tangible that will be used as the blueprint for building this solution. So that's the functional and technical specifications. So we tend to see that those are incomplete, that all the requirements has not been fully translated into a functional or technical specification. That's another common issue we tend to see. Another one is there aren't any considerations of making the system resilient, or considerations of how to make the system resilient from operational disruptions or cyber security events. That's another thing. And also really not looking at or not trying to leverage standard libraries. So standard libraries for building security features. And I think, Stan will go into that a little bit more, where your security features are core and you want to make sure that you're not trying to reinvent the wheel. You don't want to get it wrong. So those are some of the common issues that we tend to see, and not forgetting not having a proper design for your user access roles and permissions. So really not thinking about that ahead of time. What else do you think, Stan?
Those are in fact great issues that arise in the design phase in general. So then let's talk about then sort of the security aspects of design, right? So how do we kind of make this better and embed, right, security into the design process? Sort of two things to think about. One is the general approach of threat modeling, right? For those of you who may not know, threat modeling is an exercise where you really look at the architecture of the application, perhaps its components, and try to understand the threats that may arise to the system as a whole, as well as to its components. It's a little bit of a detailed exercise where you do things like list threat actors, which could be insiders, your own employees. It could be customers who are malicious or perhaps make mistakes in their interaction with the application. But whatever the actors are, you list them. You list threat vectors, mechanisms, and approaches to how these threat actors can attack your application or its modules, and you list consequences. What's the impact that for example, someone tries to guess the login password 10 times in a row? Will the system lock them out, or will it allow them to continue, right? Potentially for many more attempts until they guess the right one. So the point of this exercise is to think critically about your application and ways people can attack it. For example, Javarin mentioned file uploads. That could be an attack vector too. And then articulate what the risks are, right? You can use things like low, medium, and high. If it's a more quantitative approach, which is a little bit more difficult, you can get into dollar figures and so forth. But there needs to be some way of articulating what the risks are from the threat modeling exercise. Threat modeling, by the way, also includes attack surface modeling too, where again, you think about the threats and what are the different ways that they can get in. So there may be some obvious ways, but if you really look at attack surface, right, which is all the ways that users as well as systems and computers and service accounts interact with their system, what are the different ways that they can interact and therefore potentially, right, can cause harm through some of those interactions. That's what we mean by attack surface modeling. Once you have your threat model in place, then you can take the next step, which is controls rationalization. You can then think through both existing controls that exist within the application or in the environment, and also introduce new controls, right? You're now introducing security design elements which help mitigate some of the threats you just identified through the threat modeling exercise. These, again, can be based on best practices, or frankly, they can be based on regulations as may be needed. For example, maybe a control may not be obvious from a risk perspective. However, a regulation may require the control. Again, which is why understanding regulation and understanding the very things like privacy implications and so forth are relevant all the way from the beginning, so that you understand the bigger picture of what things you need to protect. So the point of security design is to do a threat model and come up with these controls to understand how to mitigate the risks that you see in design early on. And the kind of questions you can ask during these exercises, now we're getting a little more specific, is, for example, you can use frameworks like Stride or Dread or others. Those are actually specific threat modeling frameworks. They're used by many organizations, for example, Stride in particular. They guide the assessor through the threat modeling exercise to help you systematically and consistently identify risks within and across applications. It makes sense that if you have different people at different times assessing the same or different applications, depending on schedules, depending on who's assigned to the project, who has had to leave the project, who's on vacation, and so on and so forth, you want different individuals to think about the same risks in a different way, rather in the same way, excuse me. You don't want, for example, two different people to assess the same risk and come up with very different risk ratings. One labels it high and the other one labels it low. No, the purpose of something like Stride and Dread is so that you consistently, reasonably consistently, can articulate the same risks by different individuals, so that you can think about controls the same way. You can compare apples to apples as you assess different applications and so forth. So that's the first point in secure design, is to use these frameworks. And the second point, of course, and we'll mention this again in the future too, is make sure that the issues and controls that you've identified in this exercise actually map to the requirements phase that you set out. Remember, the requirements phase is a bit of a high-level exercise where you think about security as well, hopefully. And so here, you want to make sure that the controls and design choices you made then to protect the application, in fact, have now been realized in the design phase. It doesn't make sense to identify some security requirements in the beginning, only to find out that in the design phase, you've forgotten about some of them. So again, you want to have a mapping, you want to keep track of requirements all the way as they flow through the application, and make sure you don't forget them or they don't sort of fall through the cracks as you continue all the way through release. Right. Javari, you want to talk about maybe some more detailed questions that you may want to consider?
Yeah, definitely. And thanks for walking us through that, Stan. And thinking about the controls rationalization, we're talking about the security. You also don't want to forget about your business controls also, your automated controls and how that may change with the new system. So some questions within the design phase. Again, the design phase is pretty critical. There are a lot of questions, but for the sake of time, we could talk about this all day. Let's deal with maybe about 3 or 4. One key thing, especially from a security perspective, you can ask is, have we identified all third-party applications or all internal applications that will be connecting to this new system? Like you want to be able to ask that question. And I think later on we'll have some examples or some tools that you can use in order to help mitigate the risk of you using third-party applications. So you want to ask that question. You want to find out, how are they securing these third-party applications? There's a term, it's called an application secret. So those include your API keys, private keys, connection strings. All those are secrets of the system. So you want to ask, how is the implementation team going to secure these secrets? You want to find out, what backup or rollback procedures does the team have in place for the system in case it crashes? You want to make sure that they have that documented. You also want to find out, have they separated security functions from other functions? This is pretty detailed, but it's really important because as part of NIST 800-53, which is a standard, a framework when it comes to information security, a best practice is creating separate modules for security and separate modules for functions. And so you want to ask about that. So if something were to happen to the business functionality, then it wouldn't affect the security function, vice versa. Then you want to ask, what libraries that are standard that are being used. Libraries include authorization, authentication, encryption. Talking about encryption, Stan, what do you want to say about that specific point?
Sure, thanks, Sarah. Yeah, so indeed, using standard encryption is important. You don't want to reinvent the wheel when it comes to something so critical as encryption, because again, lots of regulations and industry best practices talk about the protection of data. So if you're going to protect it with encryption, you want to do it right. Again, as mentioned, from our perspective, Optimal Cipher, which is my firm, we actually deal with encryption quite a bit, and so we're happy to answer any particular questions if you have them on encryption specifically. We use industry standard encryption as well for many of our schemes. So, for example, you can do things like encrypted search using standard approaches such as randomized AS256. So again, if you have questions, we're happy to explore your particular encryption needs with you. But here, more generally, just to point out that yes, standard frameworks and development environments, whether in Java, C++, and so forth, have access to encryption libraries. So feel free to use those as opposed to, for example, rolling your own and so forth. Jari, any other points you want to mention here?
Yeah, thanks for that. Thank you for that, Stan. Definitely utilize standard encryption libraries because they are very difficult to build. Definitely. The last question would be to ask the team, is there a plan for separating production data and production, training, and test data or environments? Like, do you have an architecture for separating those out? Because you want to make sure that you have separate environments when building functionality and when you're testing it and when you finally put it into production. So we've kind of killed this this design requirement with this design phase. We spent a lot of time there, but we want to make sure that we got this point. So let's go on to the build.
Great. So the next phase in the SDLC is the coding and build phase, where we now take the designs that we just developed, and now developers create the code based on the design. A couple of points to note here. Obviously, your developers may be using, for example, integrated development environments or IDEs to develop the code, which includes version control and so forth. And in particular, depending on the maturity of your organization, a number of organizations today follow not just sort of waterfall versus agile processes, but in general notions such as a CI/CD, right? So continuous integration, continuous delivery, whereby code is developed and released as part of a pipeline. So multiple individuals will be working on potentially different pieces of code. They would be checking in the code at certain intervals. The code would be automatically compiled. Tools, including security tools, would be run against the code and so forth. And we'll talk a little bit about those a little bit later. But ultimately, it passes through this pipeline such that literally it's automated, as opposed to people thinking about where should they check in, what version they should use, what should they check out, what's my dependency on other people, and so forth. CI/CD as a process will take care of many of these issues for you, so that it's much easier and faster to develop code and release it, which is the goal, right? The faster you develop good code, the better it is from a project planning point of view, right? You're hitting your deliverables on time and hopefully on budget. So again, that's the big picture of what code and building is. And again, there's some common issues that arise here. Javari, you want to talk about some of them?
Yeah, definitely. So I'll quickly go through some of the issues because I know time is like just moving, and this is a really a topic of interest for us. So just a couple. So common issues within the code and building phases, program and logic flaws. Right? So that happens. Your developer is trying to work as quickly as possible, and there are some logic flaws. So we tend to see, and these can be expressed as missing or misconfigured system features. And that includes security features, right? So one example is an S3, an Amazon S3 bucket that has been misconfigured, and that allows public data, that allows private data to be public, right? So that's a misconfiguration error. Another common issue is an incomplete test plan. So you want to think ahead. You don't want to have a plan for testing or create a plan for testing in the test phase. It's too late. So having an incomplete testing plan during this phase, that's another common issue we tend to see. Utilizing a programming language that is either of an older version or not really used that much. So that's something that we tend to see. It's more tactical, but it's still very, very important to be able to bring out. So for instance, you have C++ versus Rust. So Rust is a programming language, which is actually very hard to learn. Not a lot of people know it, but it was created to address any memory issues that C++ tend to have when an application was built using that programming language. It's a nuance, but still, you want to think about it. Not being able to handle logs or not having a plan for handling system errors or system crashes. So you need a plan to be able to do that. You never want your system, your application, to fall into what is called an unknown state, where it just crashes and it just stays in limbo, because that's where the application is the most vulnerable. You always want it to crash into a safe state. And finally, just a lack of analysis for known vulnerabilities, right? So that's one of the things that we tend to see, right? And Stan, what else do you tend to see in terms of common issues? What could we do?
Yeah, those are indeed sort of a number of the issues that we have seen, and I think it would be useful then sort of to think about, well, kind of what can you do about this, right? How can you address these and other common issues that you may find during the build phase? So let's talk about some of those steps, right? How do we integrate security here, again, from the perspective of shifting left? The first is, again, you may have a CI/CD pipeline, maybe not, but one thing to consider is to use a static code analyzer, right? So you're building code, you have access to source code here. Use a tool to scan your code, which will give you, right, vulnerabilities that the code itself sees. Some of these tools do have some false positives, so it's something to think about. Nevertheless, they do point to potentially common problems that a number of developers may have, such as, for example, things like buffer overflows, and sort of other problems that may arise when developing code without thinking about security, right, at the low level coding perspective. So use a static code analyzer. There's a number of popular ones out there as part of your process. A second one is, if your IT security team has the expertise, and for certain critical applications, maybe mission critical, you may consider procuring a vendor just for this specific task. Consider doing a security code review. So this is not simply a static code analyzer. This is another person who's trained in security, looking at your code independently to find specific security issues therein. Maybe not in the entire code base. If you're developing hundreds of thousands of lines of code, this becomes very difficult, very costly, and in fact, maybe impractical. But maybe for critical sections of the code. Code and modules which are fundamental to the operation of the application can, in some cases, should be security reviewed to really have an expert look at that specifically and see what they find. And the third thing when thinking about secure build is not forgetting the environment where the application will be installed. Remember that your application does not live in a vacuum. It will live in an operating system. It will live in a container. It may live in the cloud. It may live in a physical server. Again, on-premise, off-premise, and hybrid mode, and so forth. The point is, you should review that environment, get an understanding of maybe what are the security issues there, including the libraries that will be used as part of the build process itself. So you also want to make sure that you scan those libraries. Again, get them from reputable sources and potentially do a scan of those libraries as you're building and compiling your code to integrate those libraries. Make sure that they're vetted and secure libraries to begin with, right? So again, you're not a little bit blindsided by using untrusted code that perhaps has never been used before. You're using, in fact, vetted code whose functionality is well understood. So those are some questions in secure build. Javari, any other points you want to make here?
Yes, definitely. Thanks for sharing that and outlining that, Stan. One of the things is really from some of the common issues. You want to be able to have very explicit rules for handling system errors and system crashes. Like, be very, very specific what kinds of errors are going to happen and how you're going to handle it. So that's number one. definitely want to have that. Create a test plan, have a test plan, and start to think about scenarios, functional scenarios. That means what the system is going to do in terms of calculating invoices, for example, and non-functional, the security, like input validation. How are you going to test that? And you also want to start creating a plan for testing access, the access roles that you've developed, hopefully during the design phase, that you begin to have a plan of how you're going to test that for users and so forth. So those are some of the things that I would think about.
Great. Appreciate that, Jabari. And now, again, getting even a little bit more specific with respect to some additional security build questions you may want to consider with your teams. As you develop secure code, think about a little bit more generically, are there internal policies, for example, corporate policies on developing secure code? Not all organizations have them, but they may have more general requirements when it comes to information security. For example, some organization may say things like, if PII data is to be sent to third-party locations, including the cloud, it needs to be encrypted. That means when you're developing your application, if you know that it has PII, you need to now invoke standard libraries, like we talked about before, to encrypt the data as you're, for example, storing it somewhere, right? Or similarly, encrypt it and make sure you have your application set up for certificates if necessary, so that you have TLS or another like secure FTP mechanisms to encrypt the data in transit. Look for secure development policies within the organization. If they don't exist, try to look for more general information security policies and extrapolate to what that means for your application. Another good source for policies is external organizations have also come up with various secure coding practices. For example, OWASP has a great collection of both tools and policies on how to secure web applications. Carnegie Mellon and the Software Engineering Institute has policies, for example, how to develop securely in C and C++, right? So there are organizations which are known and whose policies have been vetted that can be used as references, so that if you don't have your own secure development policies, you can leverage those to integrate security into development. And also, as a general point, to increase secure development knowledge within the organization, both for this application and in the future, think about doing a little bit of ad hoc training on secure development. It doesn't have to be complex. It could be as simple as having brown bag lunches periodically, where a professional either brought in from the outside or internally, or even a webinar such as this one, for example, can be used as a vehicle to train developers, so that step by step they learn what they should be looking out for based on the language that they're using, based on the application, based on the regulatory environment in which they're operating, and so forth. So again, they understand what they need to do. Jabari, any other points on secure build?
Yes. So one of the other things when it comes to the secure build is how is the team measuring that all the functional and technical specifications that have been programmed are found in the requirements document, and then vice versa. How do you make sure that everything that's in the requirements document, has been included in the functional and technical specifications? So that's one of the key questions that you want to ask. You also want to find out is, what is the plan for testing system features? Like, what's the plan for that? And what is the plan? I'm going to say this again. What is the plan for handling system errors and system logging? How are you going to do that? You do not want your system to fall into an unknown state, right? So those are some of the things here. All right, so we've kind of we've beat up the build phase. Now we're on a home stretch. Stan, take us through testing.
Definitely. Thanks, Giovanni. So the phase after build is testing. And again, like we said before, it's not just a waterfall model here. You can do build and test, kind of going back and forth and feedback. You can do things in parallel. The point is just to highlight things that you should be doing during testing. However, this phase is integrated within within your agile or waterfall or other development processes. So obviously, the point of testing is to find problems, generically speaking. This is the time when bugs are fixed, and more generally, code is moved into an environment where it's tested against specific use cases, right? So Javari talked about it, the testing plan before. Here is when this comes to reality, and specific use cases, either from before or now, are designed to see how the application handles them. And again, the goal is to think about the functional, non-functional, and business requirements that have been set out for the application from the very beginning, as many as you can, and develop test cases to make sure that the application now sort of handles them, right, as expected and as desired. Some things that may in particular be tested here, or maybe fleshed out more now that the application has been developed to some degree, and we can see how it works, is things like user experience. So you want to get a sense of everything from the look and feel of the application to workflows, to sort of ease of use, and so forth. So you can test the application against that. Also, performance. You want to test both performance of the application sort of under normal conditions. What is it like when people are interacting with it sort of during a regular day or a weekend, whatever the case may be when it's working, as well as stress. Sometimes maybe it's Christmas, maybe it's Thanksgiving and Black Friday. Whatever the case may be, there may be times when the application is under stress from users, from interactions, or other conditions. You want to make sure that the application can handle stress, and you want to build test cases to handle these scenarios, right? Again, make sure that it can withstand the load. And as part of this, like we said, a test plan is developed, and sometimes testers will also write scripts in specific languages, maybe of the testing platform itself or otherwise, to test the application, to run some fuzzy tests, sort of exploring, for example, from a security point of view, what happens if you try to change the last character of a user ID or of an accountant or of an account? Can I, for example, maybe get into a different account and log in that way simply by making some simple manipulations of the front? Scripts are developed. A test plan is created to ensure this consistency. The point of the plan is not only to test specific scenarios, but also make sure that different testers, again, if people go on vacation or different testers join the team, they can all be looking at the same thing and strategically examining the same issues in a consistent manner. Jawari, you want to talk about some common issues that people see in data testing?
Yeah, definitely. I think that's a good segue, ending with issues, and let's kind of make it a little broader and talk about common issues. So shortening the time frame for testing. Again, as you said earlier, one of the overall risks is project delays. Every project manager fears that. And so one of the things, or one of the tools or techniques that a project manager could use is to shorten the time frame for a specific phase. Testing tends to be the target for shortening. That's actually one of the common issues we tend to see, because when you shorten the time frame for testing, some features may not get tested adequately or at all. So that's a common issue we tend to see. A lack of training of end users. We're thinking, what does training of of end users have to do with security? Well, it has to do a lot with security because a lot of data breaches, data loss, malware, phishing is really because users aren't aware or users have not been educated. They're not security aware. So a lack of training is another common issue. There's no prioritization of testing defects. So you test, but not all the tests passed. So how are you prioritizing that? And so we tend to see companies and IT teams that don't really prioritize which testing defect is a low defect, which one is a critical game show-stopping defect. So that's another issue we tend to see. A lack of stress performance testing, as Stan noted. So not really creating the right and realistic environment for adequately performing stress testing, and not really getting sign off from the business and the IT that the testing has been performed adequately. Those are some of the common issues that we tend to see. So Stan, how do we go about trying to secure this phase?
Yes, definitely. Excellent, Javar. Indeed. So those are in fact some of the issues. So again, from a perspective of shifting left and adding security to all the phases, we can add security to the testing phase as well. Let's talk about some of the key elements. So one of them is to actually, in fact, to specifically, consciously test for security itself. So typically during testing, you may test for business functionality, you may test for features and so forth. But what about testing for security specifically? That can and should be done. And one of the ways of doing that is to add what are frequently called abuse cases. So we talk about use cases for testing, which is, for example, for business functionality. Abuse cases are also use cases, but they're specifically to explore security vulnerabilities. For example, if you go back to your threat modeling and think about a threat vector such as a disgruntled employee, right, an insider, what can that person do to your application once it's live? How about a customer? What about users of the application who maybe by mistake or in some cases maybe malicious intent, again, try to abuse their privileges? If a customer can log in and now they're an authorized user, can they do something like privilege escalation and, for example, become another account, right? So these are considerations where you look at potential abuses, you write them down, and you test them. A tool that can also be used during the secure testing phase is a dynamic code analyzer. So unlike static code analyzer, which we talked about before, which looks at source code, a dynamic code analyzer thinks about your application a little bit like a hacker. So for example, if you have a web application, you can use, and there's various tools out there again, popular ones, to attack your application without knowing anything about it. The dynamic code analyzer doesn't know if your application is written in PHP or C++ or has JavaScript or has SQL in the back end. It doesn't know anything. It simply tries to create harm, either perhaps as a regular person without credentials, or in some cases potentially as a user who is able to log in and is exploring what harm it can cause. So you can use a dynamic code analyzer again as part of CI/CD or as standalone to explore what harm can happen to the application based on threat actor, based on capabilities and functionality of the application. Javari, anything you want to add to this?
Yeah, definitely. So you mentioned the abuse cases. And so if we make the conversation go a level higher, now a lot of times we tend to call these negative and positive test scenarios, where you have a test scenario that says the system is able to do this, XYZ, maybe calculate an invoice, or a user is able to enter in an invoice, then you'll have a negative scenario where you would have the user is not able to change the price, right? Or a certain user is not able to create an invoice. Positive and negative test scenarios. So you definitely want to make sure that you have that also. So what are some questions, Stan? What are you thinking?
Sure. So to add to that, to these points, there are some ways of, again, of optimizing this process. One of them is, again, is to automate, right? Is to more automate testing, including dynamic code analysis, for example, if possible. If you automate this process, for example, as part of CI/CD or other workflows, then these test scenarios will not become an oversight, right? So rather than doing things manually and remembering that this has to be done, try to automate the workflow so that it's not forgotten. And also, besides the application itself, we mentioned just a little bit, do vulnerability scanning of the infrastructure itself where the application will be hosted, right? Again, it's not just the app which can lead to vulnerabilities. It could be the operating system. It could be the firewalls, the firewall rules, and so forth. Make sure that to scan the environment where the application lives, address vulnerabilities as you find them, right? Because the application and the hosting environment go hand in hand when it comes to thinking about vulnerabilities to your data. So make sure you test that as well as part of the testing process. All right. Now that we've addressed testing, let's go to the final phase of the SDLC.
Home stretch.
We're almost there. Let's talk about release. So the release process, frankly, is just that. It's a process in of itself, which ultimately moves the code from a testing phase into production and go live. Various things happen generically speaking. One of them is configuration management. You have to ensure that the system is properly configured as it's installed in production. You need a backup plan. Just in case you install and something goes awry, you want to be able to revert quickly to a previous version, or otherwise to some state where the system's not in limbo and customers don't know what to do. So a backup plan is paramount. Thinking a little bit ahead, you also want a support structure. Once the system is live, questions may inevitably arise. How do I change my password? The system is behaving too slowly. My shopping cart disappeared. Whatever the case may be, you want to have not necessarily a call center, but a person, a team, perhaps a managed service provider outside the organization, some process whereby there are people or chatbots or something in place which can support the application once it goes live. So in case something is wrong, people know who to contact. And of course, finally, which is probably the most important step in release, is actually then installing the application into the production environment. That's the very last step. And now you're in a go live state. And of course, like in all the other phases, there are common issues with release as well. Javar, you want to talk about some of them?
Definitely. So some of the common issues with the release phase, not having a go live checklist. What is a go live checklist? This is a very specific checklist that lists very important and critical questions or project milestones that either needed to be met or questions that needed to be answered a specific way before the application is allowed to go live. That's a go live checklist. So you want to make sure, so that's something that we tend to see that it's either non-existent or it is existent, but it's very it's not sufficient. It's not in sufficient enough detail. So that's one thing that I tend to see. Another thing is, as Stan pointed out earlier, you want to have a dedicated team once the application goes live. So a lack of a maintenance plan. So this maintenance plan, which includes a dedicated team, an IT, and a business lead, that maintenance plan is called hypercare. Hypercare is that's a term that's usually used with large scale ERP system implementations like SAP and Workday or NetSuite, but hypercare is having a dedicated team. Not having a maintenance plan is something else that we tend to see, and a lack of key performance indicators to measure how the application is performing. So not knowing whether it's doing well or not doing well, not having clear metrics. So those are some of the common issues that I tend to see.
Awesome. Thanks for that, Jabari. And then, of course, then how do we make the release process secure given that we see some of these issues? Again, several points to consider, and there are others too. One of them is to set up default configurations for the software. So when you install the software in a go-live scenario, you remove things like obvious passwords for the administrator that perhaps are common or everybody knows, right? There are specific best practices on configuration, which should be taken into account, and they should be part of the default configuration. Ensuring there's a software patching process available too. If you need to ever update the software, and potentially you will, you should think about how do you go about doing this in a least obtrusive way, so that there's not significant downtime, your maintenance windows are not too big. Ideally, it's an automated process, and so forth. Again, thinking about patching, maybe you can do things in piecemeal with respect to application, whatever the case may be, that should be part of the process as you think about releasing the software. And of course, hardening the infrastructure. We mentioned about vulnerability scanning before, but hardening the infrastructure where the application will live, turning off unneeded ports, setting up proper firewall rules, using known builds, right, which have hardened infrastructure as opposed to, for example, perhaps trying to come up with builds last minute, which may have not been vetted. Try to be prepared to use known vetted components of the infrastructure so that your application lives within a hardened environment. Jabari, you want to talk about any other questions to consider for this?
Yeah, definitely. Thanks for that, Stan. And so, one of the things you mentioned is, hardening the infrastructure environment. And, that's really, when we talk about hardening, it's really taking out, having either a server or software. So when something is being hardened, it's really taking out unnecessary services or disabling unnecessary user admin accounts. So really making that software or that piece of server do just what it needs to do and nothing more, nothing less. So that's one of the things that we think about when we talk about hardening. So when we're thinking about the release phase and what are some of the questions that we can ask, is one, do we have metrics in place to monitor the application's progress or the performance? Like, what are those metrics? If it's a e-commerce, for example, one of the metrics could be how many orders are we able to process in 10 minutes? Does it meet our requirement from way back in the requirements phase? Remember, we have requirements, then you may have a metric that goes against that requirement. Is there a dedicated team in place to handle the new application if there are any issues? Have we performed a final security assessment to ensure all the parts that are connecting to the system are secure? Now, this term of final assessment is usually called a final security accreditation. So this is where similar to a go live checklist, you have a list of security specific questions, some including, has the developer access, has that been stripped? Have we made sure that the developer hasn't included any Easter eggs? That means any backdoors in order for them to be able to get back into the system. Have we checked that? Again, have we made sure that admin accounts that are not needed have been disabled? So that's called the final security accreditation. I haven't seen that. I've only seen, from my experience, one industry, which is actually a financial services company, that actually had a very robust, almost 20-page security accreditation file, which I thought was a really, really good practice. And just making it sure that you have, again, a dedicated team. I can't emphasize this enough, but really having a dedicated team. Those are some of the questions that I would ask within this phase. So I think we've pretty much gone through everything here, Stan. We've gone through all the 5 phases, issues, how to secure it, and then questions. So there was a lot of, information. Stan, is there anything else that you feel like, anything critical you think that we probably missed or need to harp upon again?
No, I think this is great. We covered sort of all the phases and what the points are for each. And again, our overall goal in this presentation is just to point out that first of all, you can have security controls and considerations for each of the phases. And the main point is, the earlier you start to do this, the better it is, especially from a cost effectiveness perspective. It's, again, as we said in the beginning, the later you uncover and try to remedy security problems, the more costly it will be for your teams. So our goal here was to show you that hopefully you could do this faster and with less money the earlier it is. But that in general, through each of the phases, they each have their own considerations so that the final release is a secure piece of software. Javari, any final thoughts?
No, I think I can only, think about the old Beyonce song, which is like, to the left, right? Where you got to shift everything to the left when we think about security. So, so to all my GRC professionals, when you're thinking about SDLC, think Beyonce, to the left. Probably don't want to think like that, but anyway, anything that will help you to remember some of the considerations. Again, we'll have our information available. If you have any questions for myself, Javari, or Stan, happy to entertain them. Thank you. And we hope that you enjoy the rest of this day. Thank you. All right. Bye.
Thank you.